So our next workshop will be by Damian from Aleph 0, and it will be on Beyond ZKPs, MPC. So please welcome Damian.
Right. Awesome. So for those of you who have been to the previous workshop, this one will have a very different format, and we'll be more talking about practical things, about practical design of protocols. And the main goal here is to see what are the limitations of designs based purely on zero-knowledge proofs, on ZK snarks. Okay, so what are these properties, or what are these functionalities which we might want for our products that cannot be really achieved using zero-knowledge proofs alone, and might require some help from more powerful technologies like MPC or trusted execution environments. Great. So my name is Damian. I am with Aleph 0. And let's start with the application that we want to talk about. So this is something that we want to build in this talk. We want to build a private crowdfunding platform. And what do I mean by that? So first start with crowdfunding in normal setting where everything is public. We have some kind of a project that requires some funds. And basically they are looking for funding. So there are these users of the platform who come and make these contributions. Little by little, they collect some particular amount. So there is a deadline called the end date. And if at the end of the funding period there is enough money, so that the amount is larger than some pre-specified threshold, then the funding succeeds, and actually the project takes the funds and starts building. And then there might be some, benefits for the users. They might then get some return. This is not the concern of us today, but just running the crowdfunding. On the other hand, if the amount is not enough, so less than the threshold that we wanted, then the crowdfunding fails and everything is returned to the users who contributed. Okay, so this is the general shape of a crowdfunding platform. And now we want to make it private. So, well, we would like the contributions to be hidden, right? So instead of seeing someone is paying 10 USD, we just see someone maybe paid something, but we don't know how much. So ideally, we would like to have both these properties. Contributions should be anonymous, and contributions should have hidden amounts. In some designs, we'll get one but not the other. That's why I'm separating them. Okay? Anonymity here means that we don't see who is performing a particular action. Privacy means that we not only don't see who is performing some action, but we don't even know what the action is. So in this case, going beyond anonymity would mean hiding also the amount, right? Good. So then another privacy property that we would like to have is to hide the total amount. Okay, so people are making contributions, and normally we see this count live, how much was collected till now. Maybe there are some cases where we would like to hide it. We don't want everyone to know what's the current total amount. Maybe because, yeah, it's just more interesting then. But there might be other cases why I want that. So there are also two flavors of this privacy constraint. One flavor is that at the end of the crowdfunding, the total amount is revealed and everyone learns that, okay, we wanted 10K, but actually we collected 100K, great. But there might be also an even more strict privacy property that even at the end, nothing is revealed. Okay, so the total amount is not revealed. What happens only is that we learn one bit, the bit being whether the crowdfunding succeeded or not. And then this money goes to the founder and they do something, okay? So this could be like a very, very private crowdfunding then. So these are our objectives here, okay? This is what we would like to achieve. And let's go step by step and see how we can build it. So if we start with a public blockchain and standard smart contracts, and, essentially crowdfunding is probably what you see in the first Solidity tutorial, and it's quite easy. It's just basic smart contract functionality. But the one that you get from this Hello World tutorial is probably not going to satisfy all these privacy requirements. Actually, it will not satisfy any of them. Because the contributions which are made to the contract will be linkable to particular blockchain accounts, so it's not anonymous. Of course, the amounts will be in the plane. And also, we will see all the time what's the total amount, so nothing is private here. Good. So one could say, okay, so there is this smart trick that you can do even on public blockchains of using a commit reveal phase. So instead of just sending your contribution, your amount to the contract, you could first send this kind of a promise that I will contribute, but I will not tell you how much. You just commit to this amount by, let's say, hashing it with some salt and then sending this to the blockchain. So then once the crowdfunding ends, we stop accepting these commitments and then we reveal. So we ask each user who actually send a commitment to reveal the amount and send this particular contribution. So of course, let me first analyze this, assuming that the second phase goes the way we want it. I mean that every user reveals and everything is according to the law. So in that case, we actually achieve this second property, that the total amount is revealed only at the very end of the crowdfunding. Because till the second phase, we don't learn anything. And once the second phase starts, we cannot accept any more contributions. So it's kind of locked. So this is great. We will learn the total amount only after we stopped accepting contributions. So this is kind of what we wanted. And it would be good. The only thing is that we would need a mechanism here to actually force the reveal, because this is a two-phase protocol and it's not so easy, right? So we could ask the user to put some collateral. We could do some kind of tricks, but I would say even though if this is possible, then it would be kind of annoying for the user, that they need to do multiple actions with some time between them to participate. So it's annoying and it's not bulletproof. But yeah, it's something. So to improve upon that, we need to go to the realm of zero knowledge proofs. So, well, here there is a short recap of what we are looking at. So there are snarks. And with snarks, we can prove that some kind of relation is satisfied when input with a statement and a particular witness the prover holds. So I will not explain this very thoroughly. So let me just go over it very quickly. So you want the prover to generate the proof that a particular statement is satisfied. The proof is then small. The proof is easy to verify. And the proof does not reveal anything about the witness. Okay, so what do we build with this kind of a primitive? I will not tell you how to build it because for this it's best to maybe just read one of the great white papers. So the first one I think is Zero Cache. And all what I will be talking about now in this next couple of slides is the foundation of all of the designs of these protocols that I list here. So Zero Cache was the original white paper about shielded transfers. Then Zcash was built upon that. This was like very early on. But then many protocols joined. And this is kind of a long list of what happened, including Aleph 0, of course. And the last protocol that I mentioned, ZKP, is some kind of a generalization of that. But it also kind of fits the model that I will be explaining here. Okay? So, long story short, all these protocols work roughly the same. And there are subtle differences between them, but the overall model is the same. Great, so what's this model? The model is that there are two parts of the state. Global state, this is what you have on public blockchains. Public blockchains are just the global state and everything sits there. But in this privacy preserving protocols, either for payments or for other things too, you also have private state. And the private state is, each user has its own private state. Okay, so the private state is really divided into these little regions. Each user has one region of data that only he or she knows, right? So technically, this little region, the state in this region is committed to the chain, but not in the public, not in the plain, but as some kind of a cryptographic commitment that only the user can then kind of reveal or decode. Okay, so this is how you should think about the state. The more complex thing is how the interactions work. So the interactions, meaning what happens when sending transactions, when interacting with this state. So here is roughly how it works. When the user sends a transaction, the transaction will typically touch both the global state and its private state of this particular user. So as in the normal blockchain, this transaction will change the state of the global public state. So you can see there is the state transition, and the state transition means that there was a previous state and there is a new state, both for this global state and this user private state, right? Something changed. Also, there is this blue part here, which is sending some kind of asynchronous messages here. And this is, we'll see it in a second, this is a way for the user to interact with other users. Because if he keeps playing with its own private state, then yeah, this has some expression power, but it's not so much. If there is this additional ability to send some kind of private messages to other users, then you can also do transfers which are fully private. So this is this is a little bit subtle. What does it mean for the private message? Think of this as you take so in Bitcoin. So basically, you send a transaction which spends some coin, puts a little bit of this coin on your account and the other part on some other account. But what does it really mean? It means that you created this UTXO with a particular spending script or spending keys, right? So now the user who has the spending keys, they can basically spend this particular UTXO, and it's similar here. You will send this private message to someone, they can spend it, they can kind of add it, merge it into their state, but they don't have to, they can just ignore it. Similar with UTXO, you can just ignore that you got something from someone because you don't like it, and yeah, maybe it was something you weren't supposed to get. Anyway, this is exactly similar. Obviously, how do we use secret snarks here? We prove that this state transition is correct. There will be rules, obviously, what is a correct state transition. So if I have 100 coins and this says I have 110 coins, well, it cannot just happen out of the blue. Some coins have probably moved from global state. Maybe I claimed some airdrop or whatever. So everything needs to still make sense. And the fact that it makes sense, the user will prove using a snark. Why do we need a snark? Well, the chain doesn't know the private state, nor any of this. So you need to put this state in your witness and then make the proof. Okay? So this is a proof which keeps your state, the private state, private, as we want. Great. So how do we keep everything private? How do we make sure that others cannot really link our transactions? So these states are committed to the chain in a Merkle tree, and this Merkle tree is never pruned, so nobody actually knows which state is spent, which is not, and so on. So yeah, there are some kind of technical tricks how to make it work. And yeah, I encourage you to look at the Zero Cache paper. It's the simplest probably, but it has all the ideas. You want to learn it. Great. So now we can upgrade our solution and use ZK snarks to run crowdfunding. And the simplest possible way to do that is basically to keep your funds private, and if you make a donation, if you contribute, you just reveal it, okay? You reveal that you make a contribution of 10 USDT. Okay, so your private state will update from 100 to 90, and the global state, which contains the state of the crowdfunding, will increase by 10. Okay? So what do we achieve here, really? Because this sounds silly. We need to remember that everything which happens here, private state, is anonymous. Okay? So we never know which user just made a transaction. We only see that there was a contribution made of 10. And everything else is hidden. So what we achieve is anonymity here, which is good. What we don't achieve is hidden amounts, because we still have this visible, and we didn't really achieve anything about this constraint of total amount not being revealed, because whenever someone makes a contribution, it is visible. So it's still the same, only it's anonymous. So that's good, but it's maybe not ideal. So let's try something better. And well, maybe we could instead keep in our private state a record that a contribution to the crowdfunding was done. So when we make a transaction, we move some of our main funds to funds marked as contributions to the crowdfunding. Okay. So this is how the state transition would look like. Note that this is now private. So an outside user sees essentially nothing. He might see that there was a contribution made to the crowdfunding, but nothing else. And in phase 2, once we stop the contributions, we stop funding phase. We ask the users to again release the funds somehow. This is again tricky because it's similar to this commit reveal solution where we ask the users to do something for a second time. This time it's actually easier to, it's easier to force it because we might force it with the state transition that, well, the user is not able to spend this in a different way than just releasing the funds. So yeah, there are better tools to actually force the user to do that. But still, yeah, we need this second phase for the users to actually release the values. So, so what we really get here is anonymous as previously, but now we also have that this total amount is revealed late, only after the contribution phase stops. Okay, so it's okay, but maybe not everything is perfect. Good. So can we do better? Well, to do better, we need to first understand what is limiting us. And the limiting factor is here that when using this shielded model, when using just pure ZKPs, every piece of state is held by at least one user. So you could ask why? Why is that? Why are we assuming that? Well, you need to really assume that because whenever someone makes a transaction, then he or she proves that some statement is true about the state. So if there is a piece of state that nobody knows about, then this state is lost essentially, because nobody will be able to prove anything about it. So this is a limitation coming from zero knowledge proofs. There needs to be a prover, right? And if there needs to be a prover, every piece of state needs to be known by someone who can be the prover, right? So there is this consequence that in this model, this shielded model, it's really not possible to keep the total collected amount hidden forever. Why? Well, because this number, this total collected number, is some kind of value which cannot be known by any single user, right? Because they are making contributions. Everyone knows their own contribution, but if you want to keep this secret, nobody can know the total contribution, right? So this would be a part of the state that is not held by any user, right? So contradiction, right? This cannot be done in this model. And then if you think a little bit more, you will also realize that you cannot really reach a protocol where individual contributions are also hidden. This is a consequence of the first consequence, but it maybe requires a little bit more of thought. Okay, so now we know the limitations. Of course, I would say this is not exact science, since I kind of gave an argument, but this argument makes some assumptions and, well, maybe, yeah, if you add a little bit of, if you mix a little bit of other cryptography, then you will be able to overcome that. But I am kind of referring to a specific model, this shielded model of computation. In this model, this all is true. Good. How to go beyond that? How to go beyond the limitations? Well, we need some more powerful crypto primitives, essentially. So what we did before was something like the user sends a transaction, then they, like this is a slight variant of the previous solution, where instead of committing some contribution to the state of the user, they are committing it to a piece of the state which goes kind of to the initiator of the crowdfunding. Okay, so this is some kind of UTXO which is spendable, but only after the crowdfunding ends. Okay, so you could do that as well. It's a simple variant of what we talked about before, but now we will have one more piece in this whole system, which is a trusted party. And yeah, for those who wonder why Tom Hanks just appeared here, Google the most trusted person in the world. You will see why. So apart from sending this transaction, the user has now the responsibility of informing the trusted party of what the contribution was. And well, in the second phase, the trusted party will aggregate all the contributions and just reveal what the total amount was. Okay? And then, if the total amount was big enough, then the crowdfunding succeeds and the initiator will be able to claim all these funds, and if it fails, then well, everything goes back to the original contributors. So this might sound a little bit silly. Trusted party, well, we cannot do that in crypto, right? But it's only to maybe demonstrate some idea of what we are trying to do. Of course, we will not use Tom Hanks. That would be probably too expensive and he would not agree. But we will use some primitives that emulate this trusted party, that try to achieve exactly the same thing, right? But by using either software, cryptography, or hardware. So this is the idea. So now, let's analyze this solution very quickly. If assuming that we can kind of trust the initiator, then the solution here is not only anonymous, but the amounts are also hidden. So this is really great. Also, we learned the total amount at the very end. Only the last little property is not really satisfied. So yeah, can we do better? So yeah, the first question we would like to answer is how can we realize this trusted party? And essentially, there are two ways that many crypto projects are actually exploring. One is multi-party computation, the cryptography solution, software solution, and the other is trusted execution environment, which is hardware. In this talk, I will talk about MPC very, very briefly. So what is MPC? MPC is a trusted party which consists of a committee of nodes. Right? There are nodes, and they run some kind of MPC protocols. MPC protocols are protocols that deal with secret values without revealing them. They can make computations on these values. One particular protocol that you could use is BGW. You can read on that. It's quite old, but yeah, I always encourage people to look at the original papers. It's a very nice paper. So as long as enough parties are honest, the protocol will correctly compute the output of a particular functionality without revealing any of the inputs. Okay? So this is exactly what you want. This is exactly how we think about the trusted party. Good. So if you put on top some verifiability or auditability of the protocol, then you can even get the last property that we wanted. So this would be a perfect thing to have this MPC running along the Schilder model. And that's it. Thank you.
Great. Thank you. Unfortunately, we don't have time for questions at the moment, so please give a warm round of applause to Damian. Thank you. And next up is Kat from Aztec, and he will be talking about, she will be talking about Noir, ZK intuitions, so thinking like a circuit, I believe.